guys, in this video we are talking about parallel and perpendicular lines. So if you haven't yet added this to your notebook, please add it to your table of contents and turn to the next open page so you can take your notes. So today we are talking about parallel and perpendicular lines. So first you need to know that parallel lines have the same slope. So for example, 3 halves x plus 5 and 3 halves x minus 2. Doesn't matter about the y-intercepts, they just have to have the same slope. Another example would be y equals negative 5x and y equals negative 5x plus 1. So they both have a negative 5 for their slope, so they are parallel. In contrast, you have perpendicular lines, and they have opposite reciprocal slopes. So, for example, if this one is y equals 3x plus 4, the opposite reciprocal, 3 over 1, would turn into 1/3, and then a positive becomes a negative. So it's y equals negative 1/3 x minus 1. Here's another example, negative 2/5 x. This has to turn to its reciprocal, which would be negative 5 halves, and then the opposite reciprocal. So y equals positive 5 halves x. So again, the y-intercepts don't matter. It's just that parallel lines have the same slope, and perpendicular lines have opposite reciprocal slopes. Parallel lines. All right. So here are your two lines, y equals 1/2 x plus 4 and y equals 1/2 x minus 2. I want you to pause the video here and then graph those two lines. All right, welcome back. So in the red one, we should have started with a y-intercept of 4, of course, and then a slope of 1 over 2. So rise up 1, go over 2. And it would turn out looking about like this. Okay, so for the purple line has a y-intercept of negative 2. Rise up 1, run 2. So hopefully when you graph them, you could see that they are actually parallel. So what do you notice? You should notice that they're parallel. Even though they have different y-intercepts, they increase at the same rate, which is 1/2. Another type of problem that you could see, they could ask you to determine if two lines are parallel. So sometimes one might be in a different form. For example, this is in standard form, and so you can't just tell right away if this has a slope of negative 1/3, because remember, you can't just look what's in front of the x, you have to actually put it into slope-intercept form. Okay, so try to pause the video and put this into slope-intercept form. Okay, so hopefully you got something like this. Now if I simplify, I would get y equals, and negative 2 over 6 is negative 1/3 x plus 2, and all I care about are the slopes, so you can see that those two lines are indeed parallel. So another kind of problem you could see is, say, something like write an equation for the line that is parallel to y equals negative 2x plus 3 and passes through the point negative 3, 5. So what do I need from this line? Only the slope. So all I care about is that m equals negative 2. Now, you've done problems like this before. So you've done a problem with a slope and a point. So now all you have to do is find the equation of the line that has this slope of negative 2 but goes through this point. Okay, so you could use point slope form, or if you're not comfortable with that, you can use slope-intercept form. So I'll use slope-intercept form. So I have y equals mx plus b. I put my point in here. And then I can put my slope in of negative 2. So I have 5 equals 6 plus b, subtract 6, and I have that b equals negative 1. Okay, now some people will forget that they need to go one step further than that. So remember that you know that you need a new equation that has a slope of negative 2, that has a y-intercept of negative 1. So don't forget the final step is to actually write the equation, which would be y equals negative 2x minus 1. And now you have found an equation that's parallel to negative 2x plus 3 and passes through the point negative 3, 5. So pause the video and graph y equals negative 1/2 x plus 3 and y equals 2x plus 4. And although it might not be perfect because I'm graphing without a coordinate grid, you can see here that that does look pretty close to a 90-degree angle, and it would look a lot more perfect if I was using a ruler and graph paper. So hopefully you can see that those do come up perpendicular because one is the opposite reciprocal of the other. So the first thing we're going to do here is determine if the two lines are perpendicular. So remember, you need to put that into slope-intercept form so you can identify the slope. Okay, so pause the video and try that. Welcome back. So of course I'm going to add 4x to both sides. So I have 3y equals 4x plus 2. I'm going to divide by 3. And I have y equals 4/3 x plus 2/3. Okay, so I see here is negative 3/4, and here is a positive 4/3. So those are perpendicular. Okay, lastly, what we're going to do is write an equation for the line that is perpendicular to y equals 5x plus 3 and passes through the point 10, negative 2. So if we're starting with a slope of 5, we know that the slope we're going to use is negative 1/5. Okay, so you can use whichever method you want. I'm going to use slope-intercept form. So I'm going to say negative 2 equals negative 1/5 times 10 plus b, so I can solve for b. So if I multiply these together, that gives me a negative 2 plus b. Now I'm going to add 2. So my y-intercept here is actually 0. So if I go to write my equation, I have y equals negative 1/5 x. And since my y-intercept was 0, I just leave it like negative 1/5 x. So y equals 5x plus 3 is perpendicular to y equals negative 1/5 x. And this equation does pass through 10, negative 2. All right, thank you very much, and I will see you next time.